Okay, we're going to take a look at the creation of a parabola, which is the graph of a quadratic. And it's a familiar shape to you. It's either in the shape of a U or an upside down U. But we're going to look at how it's actually generated. And we're going to start by looking at two lines. In this case, we have x minus 3 and x minus 1. And we're going to think about what happens if we multiply these two lines together. And what that really means is that we're going to take the y values at any point and multiply them by each other. So, for example, suppose that we have for x value of 5, the blue line's y value is equal to 2, the red line's y value is equal to 4, so when we multiply them, we get a value of 8. If we set the x value to 4, well, now we have a blue y value of 1 and a red y value of 3. When we multiply, we get a value of 3. So what that means is that as we move this thing along here, this value that we show right here is just always going to be equal to the y value at that x value for the blue times the y value at that x value for the red. So a couple important things to make note of. So there's also this purple point right here. And what this purple point does is it has the same x-coordinate as this green point, which we're moving along the x-axis. But its y value is equal to this product here of the blue y value times the red y value. So right now it's equal to, let's move this x to 4. And because the blue point has a y value of 1, the red point y value of 3. 1 times 3 is 3, so the x-coordinate for this purple point is 4, but its y-coordinate is equal to 3. And notice now as we move, this purple point is moving closer and closer to 0 until what happens right here when the blue line is crossing the x-axis, which means that its y value is 0. Well, now when we multiply 0 times whatever the red value is for the y value for the red point, we're going to get 0. That's why our purple point now has a y value of 0. Notice, though, as we keep moving along here, the purple point goes lower and lower, and it has a negative y value because we're multiplying a positive y value for the red of 1 times a negative y value for the blue, negative 1. And so what that means is that, and so therefore our purple point has a negative y value because we're multiplying a positive times a negative. Well, notice as we keep moving this point, now the purple's starting to come back up again toward the x-axis. And again, when we're at a point where one of the lines crosses the x-axis, which means that it has a y value of 0, our product is again 0. So our purple point has a y value of 0. In this case, we're multiplying negative 2 for the y value of the blue point times 0, the y value of the red point, giving us a y value of 0 for the purple point. As we continue to move this, now notice that our purple point is now above the x-axis with a positive y value, and the reason for that is now both of our blue and red points have negative y values. When we multiply negative times a negative, we get a positive. And so we can watch what happens to this purple point. It traces the path, and this path is actually tracing a parabola. The parabola looks like this. So as we move this, we can see that the purple point moves along this green curve here. And so we can say that this parabola is a result of multiplying the line x minus 1 times the line x minus 3. Now we're going to take a look at some of the properties of this parabola. So, for example, we have what's called the vertex. And the vertex occurs at the minimum value for the parabola. And it's right at the bottom here. If the parabola was upside down, it would be right at the top. And so, therefore, another thing to take note of is that this parabola is completely symmetrical. It has a left and a right branch, and those are mirror images of each other across this line here, this line which we call the axis of symmetry. And the axis of symmetry is a vertical line, which means that it has an equation of x is equal to something. In this case, x is equal to 2. And it passes right through the vertex. And notice that the left half of this parabola is a mirror image of the right half. Now, the vertex is the one point that doesn't have a mirror image because it's right on the mirror itself. So one of the points that we care about is what's called the y-intercept. And that's the point where this curve crosses the y-axis. So when x is equal to 0, y is equal to 3. So we say that the y-intercept has a y value of 3. And that makes sense because when we take the version of this equation x minus 1 times x minus 3, again, that came from the two lines that we're multiplying, and we multiply it out by expanding it, we get x squared minus 4x plus 3. When x is equal to 0, then both the x squared and the negative 4x will become 0, which means that all we'll have left is 3. So when x is equal to 3, when x is equal to 0, y is equal to 3. Well, notice that on the other side of the parabola, we have a reflection of the y-intercept point. It is the mirror image of this on the other side of the axis of symmetry. So when y is equal to 3, we have to go 2 units to the left to get to the y-intercept from the axis of symmetry. Well, we go 2 units to the right to get to the reflection of that point, which means that it's going to have a x value of 4. So the coordinates of this point here are 4, 3. The coordinates of the y-intercept are 0, 3. So other important points are the x-intercepts, which are the 2 points, in this case, where it crosses the x-axis. And notice that it crosses at 1 and 3. And again, these are mirror images of each other across this line of symmetry. So right in the middle, we have the value of 2. And we go 1 unit to the left to get to the one intercept, 1 unit to the right to get to the other intercept. Notice that we say that when x is equal to 1, y is equal to 0. Well, that goes right back to our equation here. When x is 1, we have 1 minus 1, or 0, times 1 minus 3, which means that this is going to give us a value of 0, which is why our y value is 0. Similarly, going back to the equation, when x is 3, we plug in x is 3, we get 3 minus 1 times 3 minus 3, we're going to get a value of 0. And so that's why it crosses the x-axis at the 2 values of x that make this thing equal to 0. X is equal to 1, x is equal to 3. So then we also have, for any given point along here, this red point, wherever I put it, it's always going to have a point that is the reflection across that axis of symmetry. So these 2 points will always have the same y-coordinate, but their x-coordinates will be different. In one case, we start at the axis of symmetry and move a certain number of units to the left. In the other, we start at the axis of symmetry and move the same number of units to the right.